Today's lesson is on rules of exponents, a power that is raised to another power. So I don't want to go over a lot of details. I just want to jump right in. So here we go. So if you have a power that is raised to another power, all you have to do is just multiply those powers together, right? Just multiply those powers together. So here we have a power to a power, so we just need to multiply the powers together. The base stays the same, so the base is x, and then 2 times 4 is 8. That's it. Power to a power, you multiply. So here we go, number 2, power to a power. So you have a power that is raised to another power. So all you have to do is multiply the exponents, keeping the base the same. So 4 times a negative 3 is a negative 12. Now, many of us mathematicians, while this is a legitimate answer, a lot of us kind of agree that we will not leave our final answer with a negative exponent. So if you go back to your rules of negative exponents, you can write this as 1 over x to the positive 12. And that way you do not have a negative exponent. So find out whether your teacher wants you to stop there or whether they want you to rewrite it without any negative exponents. And you might go, well, why? What if you forget the rule, right? If you forget the rule, remember this means x squared to the 4th power. So that means x squared times x squared times x squared times x squared. And that's how you end up getting x to the 8th power. You cannot rewrite an expanded notation when you have a negative exponent. So when the exponent is negative, you can't write it in what we call expanded notation. So just use the rule and then rewrite it without negative exponents afterwards. So here you have 2 factors. You have the factor 2 that is being raised to the 3rd power, and then you have the factor x to the 5th that is being raised to the 3rd power. So the 2 is being raised to the 3rd power, and the x to the 5th is being raised to the 3rd power. So as you know, 2 to the 3rd power is 8, and then x to the, and here we have a power to a power, so we're going to multiply those exponents. So 5 times 3 is 15. So this final answer would be 8x to the 15th power, because the 2 is being raised to the 3rd power, and then the x to the 5th is also being raised to the 3rd power. In problem number 4, you're just going to take the numerator and you're going to multiply these 2 powers together because you have a power raised to a power. So that gives you a negative 1 times a negative 3 is a positive 3. And then we're going to go back and now multiply these 2 powers together because you've got a power raised to a power. So that's b. And then 2 times negative 3 is negative 6. And that is a legitimate answer. However, many of us don't in the mathematical community, so that's a good answer. We don't like having a negative exponent. So we're going to bump this up into the numerator to get rid of that negative power. So that's final answer is going to be a to the 3rd, b to the 6th. So you might need to go back and look at a video on negative exponents if you need to. So let's just try a couple more. Okay, so here we have the negative 4 is being raised, is being squared. So each one of those are being squared. So negative 4 is being squared, x squared is being squared, and y cubed is being squared. So those are called factors, and each of those factors are being raised to the 2nd power. So negative 4 is being squared, and then x squared is being squared, and then y to the 3rd power is being squared. So each of those are being squared. Each of those, what we call factors, are being squared. And then when you have a power to a power, right, doesn't this mean negative 4 times negative 4? So isn't that why that gives you positive 16? And then here we have a power that is raised to another power, so we multiply. So that gives us x to the 2 times 2 is 4. And then y to the, since we have a power to a power, we multiply 3 times 2. So that gives us y to the 6th power. And there are no negative exponents, so we are done. On this one, there's lots of ways to do number 6. So there's lots of ways to do number 6. So let's do it one way, and then we'll go back and do it another way. We could say that 8 is being raised to the negative 2nd power, and then x to the negative 5th is being raised, and then y to the 3rd is being raised to the negative 2nd power. So x is being raised to the negative 2nd power times x to the negative 5th is being raised to the negative 2nd power. Y to the 3rd is being raised to the negative 2nd power. A lot of times it's helpful if you write things down and write some steps out. And then remember, we cannot evaluate a negative exponent. So when you have a power that is negative, you can't find the value of that. So we have to first rewrite 8 to the negative 2nd power as 1 over 8 squared. And then we can work it out and say that's 1/64. And then we have x. And because we have a power to a power, we're going to multiply those. So negative 5 times a negative 2 is a positive 10, right? Negative times negative. And then y to the, here we have another power raised to a power. So the rule is to multiply your powers. So 3 times negative 2 is negative 6. And that is a good answer. However, most mathematicians have an agreement that we will not have a final answer with a negative power. So because this factor or this base has a negative power, right, the exponent's negative, we're going to bump it down into the denominator. So that's going to leave us the x to the 10th on top. 64 is already in the bottom, and we're going to bump this down with the 64 to change that negative 6 to a positive 6. So that is the final answer. So this is your final answer that is written without negative exponents. And if you're in my class, this is what we're working right now. We're working on a power to power is the first, right, the new rule. And then our final answer cannot have any negative exponents. So this is the one we're looking for as our final answer. But this is good too, but it has a negative power. So let's try that one again, a different way, because there's multiple ways to do it. So here's another way you could do that problem. Okay, so here's another way you can do that problem. So we could rewrite what is inside the parentheses without a negative exponent. So because this has a negative power, we're going to bump it down into the denominator. So that leaves the 8y to the 3rd power in the numerator. And when this gets bumped down, it changes the negative power to a positive power. Then there's a rule that says if you have a negative exponent out here and you have a fraction inside, numerator and a denominator, you can change that negative 2 to a positive 2 if you reciprocate or flip the base. So that means the x to the 5th goes on top and the 8y to the 3rd power goes on the bottom. So here what the technique that we did is we rewrote the expression without negative powers, and then we can go ahead and use the power to power rule that says we have a power raised to another power. So that gives us x to the 5 times 2 is 10. And then remember that the 8 is also being squared. So 8 squared means 8 times 8. So that 64 goes on the denominator. And then y to the, and then 3 times 2 is 6. And then notice that we got the same answer that we did before. So sometimes when I have a negative power out here and I have a just a coefficient, I'll use this technique. And there are lots of different ways that you can use the rules of exponents. There's tons of different ways you can do this problem. So sometimes I would just do it that way. And versus the other way. Remember what the other way was? So the other way was we just said 8 is being raised to the negative second power, x to the negative fifth is being raised to the negative second power, and y to the third is also being raised to the negative second power, which is a great strategy as well. There's just, you got to try different ways. Sometimes you run into different issues. You just have to remember that you can't evaluate a negative exponent. So that's 1 over 8 squared. So that's where the 1/64th comes from. And then the x should go in the middle of the fraction. And then power to a power you multiply. And then power to a power you multiply. And then this is a good answer too. Notice the answers are slightly different because this one still has a negative exponent. And when you bump that down into the denominator, the x to the 10th stays on top, and the 64 is already in the denominator. So this, when I bump it down, goes down with the 64, and then you see you get the same thing. So just different ways. There's even a third way. I'm not going to go over it. But that's basically the power to power rule. So let me maybe go over one more. We'll go over one more. This one has multiple. It's multiplication, and it has a power to a power. So it has powers raised to another power, and it has multiplication. So you have to do the power to power first. So therefore, we're just going to rewrite 2x cubed, y to the fifth times, and then the x is being squared, so x squared, and then the y is a power to a power, so we're going to multiply those. So that's where we get -8, right? And then the x's go together and the y's go together, right? So we're just rearranging, and then we're just simplifying the chunks. So you get 2x to the, so remember when it's a multiplication problem, you add the powers. So that would be 5. And when it's a multiplication problem, you add the powers. So 5 plus a -8 is a -3, and that is a great answer. However, that answer has a negative power, so we're going to dump this down into the denominator and leave 2x to the fifth up on top, and that changes it to a positive exponent. So here's an answer that without negative exponents in your final answer. Okay, that's the new lesson.